And in this lesson, we're going to talk about physical and chemical properties and see how they differ from each other.
In general, there are two ways that we look at the properties of matter.
One is considered the physical properties, and the other is the chemical properties. What is the difference between them? Let's list it first. So physical properties are the characteristics of a substance by itself, whereas the chemical properties are how its substance behaves with other substances. So you might think of the physical properties as the way that something looks, feels, smells, whereas the chemical properties are what it does. So for example, if there was a bank robbery, you might say something like, the bank robber was 6 foot tall, he was wearing purple shirt, green shoes, had long hair, had blue eyes. Any of those kinds of descriptions are things that you could see. So you'll notice that we have things like color, size, shape. Those are all things that are physical properties. On the other hand, if you were to say what happened, that would be more of a chemical property. So did he steal money? Did he steal jewelry? Did he
have partners? Did he yell? Did he run out the door? Did he grab something? What are the things that he did? Those would be considered chemical type properties.
And these descriptions would be more like a chemical property. What did it do? Not so much what did it look like, but what did it do? And that's what we're looking at when we look at chemical properties. Now let's go into a little more detail about each of these.
So the physical properties of a substance are characteristics of the substance by itself. That means that we can look at something and describe it. So we can say it's yellow, it's large, it's small, it's shiny, it's dull. Those things are physical properties where we just look at it directly and describe it. Some physical properties have to be measured, so we might take a ruler and measure how big something is. We might have to weigh how much it weighs. We might take a thermometer to see what the temperature is. These are still physical properties because they're not changing the substance as we test them. Later, when we talk about chemical properties, we see that we might have to change the substance in order to see what its chemical properties are. These physical properties can be classified into two ways. One is called intrinsic. These are properties that don't depend upon how much stuff there is. On the other hand, there's extrinsic properties, and these do depend upon how much stuff there is. So whatever we're looking at, sometimes it matters how much there is, sometimes it doesn't. When I tell you that a banana is yellow, that doesn't matter how much there is. So color is an intrinsic property. For that same banana, we could have an extrinsic property like how much it weighs. It may weigh 100 grams or 110 grams, depending on the size of the banana. So those are still physical properties, but they do vary dependent upon how much is present. So just to let you know, I will not be asking you about this on the exam, so I won't ask you, is this an intrinsic or an extrinsic property? It's just helpful to know about it so that you realize that sometimes it does vary dependent upon how much there is, and yet it is still a physical property. Notice that as we measured or observed these physical properties, that we did not in any way alter the basic nature of the substance. When I looked at the banana and said it was yellow, nothing had to change. When I weighed it on the scale, I may have taken it and placed it on the scale, but I didn't change anything about the banana. These physical properties could always be observed or measured without changing the composition of the matter. That is not true of chemical properties, as we'll see later. The simplest physical properties can be described using our five senses. So we might look at the sight, the sound, the smell, the taste, or the feel. Many of our descriptions of physical properties depend upon our sense of sight. So we will see that we can look at the appearance of something. Oftentimes we say, what is the color, the size, the shape? Some other terms that we will be using are opacity or clarity. For example, you might describe plastic wrap on your food as clear or transparent. And you might describe something like wax paper as cloudy or translucent. You can see through it, but not clearly. And you might describe something like aluminum foil as opaque. You cannot see through it at all, and light cannot go through. Other visual clues that we may see are things like luster. When we talk about luster, that talks about how shiny it is or how sparkly or dull. So we can use luster as one of our terms. We can also see texture oftentimes is used in a description. So we might see that something is fuzzy or fluffy or maybe crystalline or powdery or rocky. Those types of terms would all be physical properties. Our other senses are used significantly less often in chemistry lab, but they can be used to describe things. So we might say how something sounds. You might say it had a metallic clink to it when you hit a bat. You could say it sounded wooden. You might say it sounded hollow or solid. So those are some descriptions we could use with sound. With smell and taste, those are generally not used in the chemistry lab for safety reasons. When you are asked to describe how something smells, you'll always be asked to waft the scent towards yourself so that you don't get a blast of it. You definitely don't want to get a blast of rotten egg smell when you're smelling something. And some things may be dangerous, so we certainly wouldn't want you to smell everything. Generally, smells are used in an associative way, and so something might smell like a banana, like a rose, like a rotten egg, like old oil, like stinky feet. There's lots of different descriptions we might have, and all of those descriptions are usually done in an associative way, so we might say it smells like something else. In the chemistry lab, we don't generally use taste as one of the senses that we use in the lab. But at home, you certainly do. At home chemistry, you might see how something tastes. You might say that your food tastes sweet or salty or spicy. Those are all descriptions that are physical descriptions of the taste. For safety reasons, again, the sense of touch is not used a lot in the chemistry lab, but we certainly use it at home. We might use terms like hard or soft, fluffy, scratchy, stabby. I don't know if that's really a word, but I certainly know it when I feel it. One of the most important physical properties that we measure and describe in almost every description that we do in the chemistry lab is the physical state of matter. Now, there are actually 23 physical states of matter that are known at this point. I'm sure there are more. But in this class, we're only going to focus on the three major ones. And that is the solid, abbreviated with the letter S, a liquid, abbreviated with the letter L, and a gas, abbreviated with the letter G. These three states are the most common ones, and you'll be asked to write those down anytime we're describing something. For example, if I were to describe water, most people would say, oh, it's a liquid. But in reality, water, the formula H2O, can be a solid. We call it ice, is its common term. Or it could be a gas, which we find in the air around us that we're breathing, and in its gaseous form it is called steam. Now it happens that water has three different terms for the three different states because water is so common on Earth. But generally, most chemicals do not have different names for them, which means that we have to describe it as a solid, a liquid, or a gas. Related to the physical states of matter, we also have things like boiling point, freezing point, melting point, condensation point. Those terms are related to the physical states of matter, but they're the temperatures at which one changes to another. So when we say that something freezes, it's going from a liquid to a solid. The freezing point of water is 0 degrees Celsius. We'll talk about these more later. While many physical properties can readily be described just using our five senses, many others need to have a measuring tool. For example, if I describe something as big, what would that mean to you? Well, it depends on what we're referring to. So we need to use a measuring tool to say what exact size something is, and that is still a physical property. These measurements will often use the measurements that we've just seen before. So you might say the length, the area, the volume, the mass, the temperature, or the number of things that are present. Those are all, again, physical descriptions that we can use, but they're going to use something to measure them. Other physical properties that you might know about are density and specific gravity, which of course are very related to each other. Viscosity, which is a property that describes how something pours. Does it pour quickly like water, or is it very slow like honey? We have something like magnetism, where we look to see if something itself is magnetic, or if it's attracted to a magnet, or if it's not attracted to a magnet. We have something called polarity, and we'll talk more about that later, but it looks at basically, does this structure have two different ends to it? We look at solubility. Does it dissolve in water? Does it hate water like oil does? We can look at conductivity. Conductivity is, does it allow electricity to flow through it, or possibly does it allow heat to pass through it? We can look at thermal expansion. Thermal expansion is how much bigger it gets as it gets warmed up. If you compare a block of cement and a hot air balloon and you warm them both up by 10 degrees, you should see that the hot air balloon will get much larger and the cement might grow a little bit, and that is its thermal expansion. We also have the term specific heat, and that is how much energy does it take to heat something up. You'll notice that it's much easier to heat the air than it is to heat a glass of water. It takes a lot more energy to heat up that water, and that's called specific heat. There are two terms that are not commonly known terms that you should know from lab that are physical properties, and those two terms are malleable and ductile. So malleable means that if I hit it with a mallet, that's how I remember it, if I hit it with a hammer, it will flatten out into a sheet, sort of like if you look at aluminum foil or you look at your car. When you hit it with a hammer, it can flatten it out and we can get rid of dings and dents that way. So those would be malleable. On the other hand, if I hit air with a hammer, it doesn't really flatten into a sheet, right? It just passes through. If I hit a rock with a hammer, it shatters, so it is not malleable. And the next term was ductile. Ductile is something that stretches into a wire. So we know that copper can be stretched into a wire, but if you tried to stretch a rock into a wire, you'd notice it would just shatter. So that is not ductile. There are many other physical properties, but this is a fairly comprehensive list. Next, we're going to look at the chemical properties of matter. The chemical properties of a substance are the characteristic interactions of that substance with other substances. So it is very difficult to describe chemical properties, and that is because measuring that property must lead to the change in the substance's chemical structure. And that means that chemical properties are extremely difficult to describe without describing the changes that occur. Some of the basic chemical properties that we look at are stability, potential to react, reactivity. So we might look at the flammability, or a similar term, combustibility. Some things burn readily in air, others don't. So your carpet might burn, but the walls may not burn. We would consider hydrogen explosive because when we contact it with a flame or a spark, it will explode. Helium doesn't, so it's not explosive. We can see some things are easily oxidized. Something like your car will rust, but the windows do not rust. So those are different properties, chemical properties. Another example of oxidation is something like tarnishing. So we'll see that silver tarnishes and other metals do not. Another type of reactivity is that some things react with water. Some of them react explosively, others just barely bubble, and some don't react at all. We see lots of different types of reactions with water, with acids. We look at the pH, it tells us how much acid is present. All of those are chemical properties of matter. Now it's time for you to try it. I'd like you to indicate whether each of the following is a physical property or a chemical property. Please pause the video while you do this, and then when you come back, I'll give you the answers. Okay, so I'll be using the letter P to say it's a physical property, and the letter C to say if it's a chemical property. So the first one, the rose is red. That's telling us the color, and that is a physical property. Next, we have baking soda reacts with vinegar. That's telling us that those two do react with each other. That's how they interact with each other, and that is a chemical property. Next, we have a sugar cube is square. Well, they're cubic actually, but the description is of a physical property. Next, we have the density of oil is 0.93 grams per milliliter. That is the property of the substance itself, and so it is a physical property.
For number 5, we have the window is foggy, and very similar to whether it's clear, transparent, those types of terminology, this is telling us that this is a physical property. Acetone boils at 78 degrees Celsius. Again, we have a physical property. That diamond is a beautiful, sparkling crystal. The beautiful is not a good terminology. We won't be talking about that. That should be an opinion, and so it's not one of our observations, really, but we could say it's sparkling and it's a crystal. Both of those are physical properties. Number 8, those pajamas are not safe. They are flammable. The flammability is considered a chemical property. Number 9, sugar easily dissolved in water. That is a physical property because dissolving is physical. And the last one, number 10, baking soda can be used to put out fires because it is not flammable. And again, that one will be a chemical property. The fact that it is not flammable is also a chemical property.